that was kind of my next question, but maybe before we jump into that,
Yeah.
let's look at how you feel operators are like right now. Why do we have this need for them?
hmm Yeah. The way I would think about it is, s- uh, so let's go back a little bit more in history again. At least from my perspective, this is kind of how I've seen things evolve. So one of the things I was doing at Pivotal, after working on this container scheduler stuff, uh, our orchestration system used etcd on the back end, very similar to Kubernetes. And uh, we had I won't go into all the details, but at some point the architecture of Cloud Foundry had two distinct etcd clusters and a console cluster. So we had three of these kind of raft based quorum systems for different kinds of essentially like ephemeral state management and service discovery.
Mm.
And our product at that time, so Cloud Foundry, was something that we would package and ship for customers to then install and self manage. So if you think about like your typical enterprise and you're saying, here's a bundle, it has two etcds plus console plus a container scheduler plus a routing tier, an identity tier, uh, and all these other things to make this complete, Heroku thing in a box. That's pretty complex. And for this to reach many customers, they're not going to have like 10 Silicon Valley, people with like 25 years experience that know all the sort of distributed system stuff and that full stack and be able to figure it out all themselves. It has to be kind of turnkey, right? That's the key.
Mm.
Like, how can you make these complex distributed systems turnkey, especially when this is just a small part of a much larger system? And so I took on responsibility for a few things. One was our kind of we were using a technology called Bosch, and I think Bosch was uh, like a precursor in a lot of ways to like Kubernetes and operators. So we had the equivalent of like a operator for console and an operator for etcd. And the key challenges came across, like it's easy enough to like run some software on some machines, right? Where it gets really hard is managing the like nitty gritty of the life cycle when you know these sort of like raft based systems, right?
Oh yeah.
They're meant to do leader election, and if there's a network partition and then the partition heals, you expect the cluster to come back and self heal.
Mm.
So we would have customers say, okay, we're going to go deploy this across like three data centers, and we're going to just pull the power on one data center, and we're going to plug it back in, and your product better, keep working. And we also want to be able to rotate certificates all the time, and we want to be able to scale up and scale down and do all sorts of troubleshooting and all that sort of stuff. So when you look at like the full nitty gritty of the full life cycle of managing these complex distributed systems, and that has to be turnkey, uh, that's when things get tricky. So what we found was we were writing a lot of code. Let me give you like a concrete example, and I think this is a problem
Mm.
in Kubernetes today. Your workloads don't know if they're going away for good or they're just being like rolled, right?
Great
So
point.
if you have a cluster, and you're removing one of the nodes because you're scaling down, you might want it to behave differently than you may want it to kind of like share its data with its peers and like move the data off, versus if it's just going down because you're like updating the OS, you don't need to do that, right? Versus if you're just deleting the whole cluster, then you don't even need to bother with the like just like delete the thing. You don't need to bother
Mm-hmm.
orchestrating cluster membership and all that sort of stuff, or do any leader elections. Like, just it should just go away. um so nothing in the like Bosch, nothing gave us as like a Bosch release author or like a Bosch operator author the hook to know about these sorts of things happening in the life cycle. And so what the way I'd kind of summarize that is distributed systems are hard, and uh, trying to provide a solution for managing certain kinds of distributed systems in a generic framework that's meant to work for everything, right? Like Bosch was meant to, or like
Mhm.
Kubernetes is meant to,
Yeah.
is really hard, right? You get this, like, the specific needs of the software and the really kind of idiosyncratic needs of the software with the generic nature of the platform, right? So like Kubernetes has certain hooks, lifecycle hooks that you can kind of write scripts for. But if it doesn't give you everything you need, or you end up having to write, you know, a lot of logic, that's kind of where some of the that's kind of why we have operators, right? Because I think a uh, to go from the generic structure that Kubernetes gives you to like the actual lifecycle needs of your software, that just requires a lot of code, I think, right? Because to make
Mhm.
that fit, and so that's why I think we have operators. I think the I think what's great about operators is it's this idea of like, you as a vendor can actually package this code that orchestrates your thing uh, in in a way that still gives a kind of a consistent experience to the customer.